ನಮಸ್ತೆ ಸ್ನೇಹಿತರೆ, ಲಾಸ್ಟ್ ವಿಡಿಯೋದಲ್ಲಿ ಎಕ್ಸಾಂಪಲ್ ನಂಬರ್ 4ನ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ಇವತ್ತಿನ ವಿಡಿಯೋದಲ್ಲಿ ಎಕ್ಸಾಂಪಲ್ ನಂಬರ್ 5 ಇಂದ ಶುರು ಮಾಡೋಣ. ಸೊ ಎಕ್ಸಾಂಪಲ್ ನಂಬರ್ 5 ಇನ್ ದ ಟೆಕ್ಸ್ಟ್ ಬುಕ್, ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ ಎಕ್ಸಾಮ್ ಆಲ್ಸೋ. ಸೊ ಕ್ವೆಶನ್ ಈ ರೀತಿ ಇದೆ: ಶೋ ದಟ್ ದ ರಿಲೇಷನ್ ಆರ್ in the set z of all integers defined by r is equal to a comma b such that 2 divides a minus b, we have to show that it is an equivalence relation. So equivalence relation andre ಏನು ಅಂತ ನಮಗೆ ಗೊತ್ತಿದೆ. equivalence relation prove ಮಾಡಬೇಕು ಅಂದ್ರೆ we have to prove that it is reflexive, it is symmetric and also it is transitive. So ಹೇಗೆ ಪ್ರೂವ್ ಮಾಡೋದು? ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ದ ಗಿವನ್ ರಿಲೇಷನ್. ಗಿವನ್ r is equal to a comma b such that 2 divides a minus b and it is defined on the set of all integers. ಇಲ್ಲಿ 2 divides a minus b ಅಂದ್ರೂ ಒಂದೇ, ಅಥವಾ a minus b is divisible by 2 ಅಂದ್ರೂ ಒಂದೇ ಮೀನಿಂಗ್. ಸೊ ಯಾವ ರೀತಿ ಬೇಕಾದರೂ ನಾವು ಬರಿಬೋದು. 2 divides a minus b ಅಂದ್ರೂ ಒಂದೇ, ಅಥವಾ a minus b is divisible by 2 ಅಂದ್ರೂ ಒಂದೇ. Now we have, this is again an infinite set. Infinite set na ನಾವು ರೋಸ್ಟರ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೆದು ಪ್ರೂವ್ ಮಾಡೋದು ಕಷ್ಟ. ಸೊ ಹಾಗಾಗಿ ಜನರಲ್ ಆಗಿ ಪ್ರೂವ್ ಮಾಡೋಣ. ಜನರಲ್ ಆಗಿ ಹೇಗೆ ಪ್ರೂವ್ ಮಾಡೋದು? we have to consider for every element belongs to the set, we have to prove that ordered pair a comma a belongs to relation. So a comma a belongs to relation ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಹೇಗೆ ಪ್ರೂವ್ ಮಾಡೋದು? ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋ ರಿಲೇಷನ್ ಪ್ರಕಾರ if a minus b is divisible by 2, ab belongs to r. a comma a belongs to r ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ವೆರಿ ಸಿಂಪಲ್. I have to prove that a minus a is divisible by 2. It's quite obvious. ಯಾಕೆ? a minus a is what? 0. 0 is divisible by all the numbers except 0. 0 ಇಂದ ಮಾತ್ರ ಡಿವೈಡ್ ಆಗಲ್ಲ, ಇನ್ನ ಬೇರೆ ಯಾವುದೇ ನಂಬರ್ ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರು ಡಿವೈಡ್ ಆಗುತ್ತೆ. So therefore 0 is divisible by 2 also. It satisfies the condition of relation. Relation condition satisfy ಆಯ್ತು. So ಹಾಗಾಗಿ what we can conclude? If a minus a is divisible by 2, then ordered pair a comma a must belongs to relation. So a comma a must belongs to relation. What we consider? It is for any a belongs to z. For any a belongs to z, we have the ordered pair a comma a belongs to r. It is the condition for symmetry, reflexivity. Hence this relation R is reflexive relation. Next, what we have to prove? We have to prove that relation is symmetric also. A symmetry hege prove madodu? We have to consider one element, one ordered pair in the relation. We have to prove that that reverse ordered pair is also in the relation. ಅಂದ್ರೆ ಒಂದು ordered pair ತಗೊಂಡು ಅದರ reverse pair ಕೂಡ relation ಅಲ್ಲಿ ಇದೆ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. So let us consider, if AB belongs to R, according to the given relation, what we should have? If AB belongs to relation, 2 divides A minus B. So 2 divides A minus B. If 2 divides A minus B, we know that 2 divides B minus A also. For example, if you want to take 6 minus 2, 4. 4 is divisible by 2. ಅದೇ ತರ 2 minus 6 ತಗೊಂಡ್ರೆ minus 4. Minus 4 is also divisible by 2. So if a minus b is divisible by 2, b minus a is also divisible by 2. So this is also satisfying the relation condition. So 2 divides b minus a, then ba belongs to relation. Hence it is symmetric relation. Now transitive hege prove ಮಾಡೋದು? We have to take two ordered pairs ab, bc. Then we have to prove that transit pair AC must belongs to the relation. Then it is transitive. So ಅದಕ್ಕೋಸ್ಕರ let us consider two ordered pairs. AB belongs to relation and also BC belongs to relation. AB belongs to relation ಅಂದ್ರೆ according to the definition, 2 divides A minus B, 2 divides A minus B. And BC belongs to R means 2 divides B minus C. Now if any number is divisible by 2, then it must be a multiple of 2. So therefore, if a minus b is divisible by 2, a minus b must be a multiple of 2. Similarly, b minus c is divisible by 2, then b minus c must be a multiple of 2. So here m and n must be integers. because we are finding the multiples. So where m and n are integers. Right. Now let us add them. Iveredu add madidre a minus b plus b minus c is 2 common ide. Let us take 2 common m plus n. So we know that if m and n are integers, their sum is also an integer. M plus n must be an integer. So what we will get here, b and minus b will get cancelled. A minus c is equal to 2 times m plus n, where m plus n is an integer. Once again we are getting a minus c is also a multiple of 2. A minus c kuda multiple of 2 alle ಸಿಗ್ತಾ ಇದೆ. ಹಾಗಾದ್ರೆ ಮೀನಿಂಗ್ ಏನು? ಇದು 2 ಇಂದ ಡಿವೈಡ್ ಆಗಲೇಬೇಕು. So a minus 2 divides a minus c also. So this is also satisfying the condition of relation. So if a minus b is divisible by 2, ab belongs to R. Here a minus c is divisible by 2, ac belongs to R. So we considered AB belongs to R, BC belongs to R, AC also belongs to R, hence it is transitive. So it is reflexive, it is symmetric, and also it is transitive, hence it is an equivalence relation. Okay, so ಅದೇ ಸೇಮ್ ಎಕ್ಸಾಂಪಲ್ ಮೇಲೆ ಕೆಲವೊಂದಷ್ಟು ಕಾನ್ಸೆಪ್ಟ್ನ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. So just now we have proved that relation R on set defined by R is equal to a comma b such that 2 divides a minus b, it is an equivalence relation. We proved that R is an equivalence relation. Now let us try to write the roster form for few elements. So ಕೆಲವು ಎಲಿಮೆಂಟ್ಸ್ ನ ತಗೊಂಡು ರೋಸ್ಟರ್ ಫಾರ್ಮ್ ಬರೆಯಕ್ಕೆ ಟ್ರೈ ಮಾಡೋಣ. 0 ಗೆ ಯಾವ ಎಲಿಮೆಂಟ್ಸ್ ರಿಲೇಟ್ ಆಗಿದೆ? 0 minus 0, so 0 divisible by 2. 0 plus or minus 2, it is also divisible by 2. 0 plus or minus 4 ಬರುತ್ತೆ, that is also divisible by 2, etc. So ಇದು what you can observe, 0 ಗೆ 0 plus or minus 2 plus or minus 4, next plus or minus 6 plus or minus 8, ಈ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ರಿಲೇಟ್ ಆಗಿದೆ. ಅಂದ್ರೆ ಎಲ್ಲ ಈವನ್ ನಂಬರ್ಸ್ 0 ಗೆ ರಿಲೇಟ್ ಆಗಿದೆ. 1 plus or minus 1, so 1 plus 1 ತಗೊಂಡ್ರೆ 2 divisible by 2, 1 minus 1 ತಗೊಂಡ್ರೆ 0 divisible by 2. Similarly 1 plus or minus 3, 1 minus 3 ಅಂದ್ರೆ minus 2 divisible by 2, 1 plus 3 4 divisible by 2. Similarly 1 plus or minus 5. So what you can observe, set of all even numbers are related to 0, set of all odd numbers are related to 1. So let us list out what are the set of elements which are related to 0. Just now we discussed 0 plus or minus 2 plus or minus 4 ಇವೆಲ್ಲ 0 ಗೆ ರಿಲೇಟ್ ಆಗಿದೆ. ಅದೇ ತರ set of all elements which are related to 1, let us denote it by this symbol. ಯಾವ್ಯಾವುದು? ಎಲ್ಲ odd numbers, plus or minus 1, plus or minus 3, plus or minus 5, etc. they are related to 1. Now what you can observe here in these two sets, ಈಗ 0 and 2 ತಗೊಳ್ಳಿ, they are related to each other. 0 minus 2 ಅಂದ್ರೆ minus 2 divisible by 2, 0 plus 2, it is divisible by 2. Then 2 minus 0, minus 2 minus 0, both are divisible by 2. 2 and 4 ತಗೊಳ್ಳಿ, difference 2 ಬರುತ್ತೆ, divisible by 2. 2 and 6, difference 4 ಬರುತ್ತೆ, divisible by 2. 2 and 8 ತಗೊಳ್ಳಿ, difference is 6, divisible by 2. ಅಂದ್ರೆ 2 is related to every element of this set, 0 is related to every element of this set, 0 difference 4 divisible by 2, 4 2 difference is 2 divisible by 2, 6 4 difference is 2 divisible by 2. ಅಂದ್ರೆ ಈ ಸೆಟ್ ಅಲ್ಲಿರೋ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ ಒಂದಕ್ಕೊಂದು ರಿಲೇಟ್ ಆಗಿದೆ. Each element in this set are related to each other. Similarly here 1 3 difference 2 divisible by 2, 1 5 difference is 4 divisible by 2. ಅದೇ ತರ 1 7 ತಗೊಂಡ್ರೆ difference is 6 divisible by 2. 1 similarly 3 1 difference 2 ಬರುತ್ತೆ divisible by 2. 3 5 difference is 2 divisible by 2. 3 7 difference 4 ಬರುತ್ತೆ divisible by 2. That means in this set also every element is related to each other. ಇದರ ಈ ಸೆಟ್ ಅಲ್ಲಿರೋ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ ಒಂದಕ್ಕೊಂದು ರಿಲೇಟ್ ಆಗಿದೆ, ಈ ಸೆಟ್ ಅಲ್ಲಿರೋ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ ಒಂದಕ್ಕೊಂದು ರಿಲೇಟ್ ಆಗಿದೆ. ಆದ್ರೆ If I consider 0 and 1, difference 1 ಬರುತ್ತೆ, relate ಆಗಿಲ್ಲ. 2 and 3 or 2 and 5, whatever you consider, the difference will be odd. Odd number cannot be divisible by 2. ಸೊ ಇದು ಈವನ್, ಇದು ಆಡ್, ಡಿಫರೆನ್ಸ್ ಯಾವಾಗಲೂ ಆಡ್ ನಂಬರೇ ಬರುತ್ತೆ. ಸೊ ಇದರಲ್ಲಿರೋ ಯಾವುದೇ ಎಲಿಮೆಂಟ್ಗೆ ರಿಲೇಟ್ ಆಗಲ್ಲ. ಸೊ ನನ್ ಆಫ್ ದ ಎಲಿಮೆಂಟ್ಸ್ ಇನ್ ದಿಸ್ ಸೆಟ್ ಆರ್ ರಿಲೇಟೆಡ್ ಟು ಎನಿ ಆಫ್ ದಿಸ್ ಸೆಟ್ಸ್. ಸೊ ದಟ್ ವಿ ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಫ್ರಮ್ ದಿಸ್. So what we have observed in this set, so in this set every element is related to each other. In this set also every element is related to each other, but no element of this set is related to any element of this set. So idella set of all even barutte, idella set of all odd bantu. Clearly yavade common element illa, they are mutually disjoint, their intersection is empty. So intersection is empty. ಮತ್ತೆ ಇನ್ನೊಂದು ಅಬ್ಸರ್ವ್ ಮಾಡ್ಬೋದು, ಇದು ಈವನ್, ಇದು ಸೆಟ್ ಆಫ್ ಆಲ್ ಆಡ್. ಸೆಟ್ ಆಫ್ ಆಲ್ ಈವನ್ ಇಂಟೀಜರ್ಸ್ ಯೂನಿಯನ್ ಸೆಟ್ ಆಫ್ ಆಲ್ ಆಡ್ ಇಂಟೀಜರ್. ಇಫ್ ಯು ಟೇಕ್ ದ ಯೂನಿಯನ್ ಯು ವಿಲ್ ಗೆಟ್ ಸೆಟ್ ಆಫ್ ಆಲ್ ಇಂಟೀಜರ್ಸ್. ಈವನ್ ಆಡ್ ಎರಡು ಸೇರಿಸಿದ್ರೆ ಹೋಲ್ ಇಂಟೀಜರ್ ಸೆಟ್ ಬರಬೇಕು. Now what you can observe, it is satisfying three conditions. One is this set, in this set all the elements are related to each other. In this set also all the elements are related to each other. First condition. Second condition is what? There is no element in this set is related to any element in this set. That means none of the elements in this set are related to any of these elements. Okay, that is second condition. Third condition, if you take the union you are getting the actual set Z. Any of these two collections which satisfy these three conditions, then especially if it is defined R is equivalence relation, then these two are called as equivalence classes. Equivalence class anta karibekalla. So equivalence class ಆಗಬೇಕು ಅಂದ್ರೆ three conditions ಏನು. First of all, especially four conditions. First of all, R should be equivalence relation. That is first and foremost condition. Second one, what we should have, each set, in every set, every element should be related to each other in this set as well as in this set, but there should not be any relationship between these two sets. And if you take the union, you should get the actual set. If any set which satisfy these three conditions, then those sets we call them as equivalence classes. So these two are equivalence classes for this particular relation R. Okay, so ಅದೇ ತರ ಬೇರೆ ಬೇರೆ ರಿಲೇಷನ್ಸ್ಗೆ ಬೇರೆ ಬೇರೆ ಈಕ್ವಲೆನ್ಸ್ ಕ್ಲಾಸಸ್ ಸಿಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಇನ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಕೇಸ್ ಎರಡೇ ಸೆಟ್ ಮಾತ್ರ ಸಿಕ್ಕಿದೆ, ಬಟ್ ಇನ್ನ ಕೆಲವು ಕೇಸಸ್ ಅಲ್ಲಿ ನಮಗೆ ಎರಡು ಸೆಟ್ ಅಲ್ದಿರ more than 3-4 sets, even you may get more than 3-5, but all those sets should satisfy these three conditions. What are those? If you consider any one set among those, every element should be interrelated. In all the sets satisfy those conditions, then there should not be any interrelation between any of those sets. Then finally, if you take the union, you should get the actual set. If any sets satisfy these conditions, they are equivalence classes. Okay, so this is, in this particular example, these two are equivalence classes. Okay, if we generalize it, if R is a equivalence relation defined on a set A, in general how we can define the equivalence class? Suppose if there exist A1, A2, etc. n sets satisfying the three conditions, more conditions ಯಾವ್ಯಾವುದು, all the elements of set AI. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಐ ಟೇಕ್ A1 ಸೆಟ್ ಅಲ್ಲಿರೋ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟು ರಿಲೇಟ್ ಆಗಿರಬೇಕು, A2 ಸೆಟ್ ಅಲ್ಲಿರೋ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟು ಒಂದಕ್ಕೊಂದು ರಿಲೇಟ್ ಆಗಿರಬೇಕು, ಎಕ್ಸೆಟ್ರಾ ಅಪ್ ಟು AN. ಎಲ್ಲ ಸೆಟ್ ಅಲ್ಲೂ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟು ಒಂದಕ್ಕೊಂದು ರಿಲೇಟ್ ಆಗಿರಬೇಕು. ಸೊ ಆಲ್ ದ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ಸೆಟ್ AI ಆರ್ related to each other. Second condition ಏನು, A1 A2 if you consider, ಅದರಲ್ಲಿ ಒಂದು A1 ಇಂದ A2ಗೆ ಯಾವುದೇ ಎಲಿಮೆಂಟ್ಗೂ ರಿಲೇಶನ್ಶಿಪ್ ಇರಬಾರ್ದು. ದಟ್ ಮೀನ್ಸ್ ನೋ ಎಲಿಮೆಂಟ್ ಆಫ್ ಸೆಟ್ AI is related to any element of set AJ if I not equal to J. ಅಂದ್ರೆ ಏನು, A1 A2 ತಗೊಂಡ್ರೆ A1 ಇಂದ A2ಗೆ ಇರೋ ಯಾವುದೇ ಎಲಿಮೆಂಟ್ಸ್ಗೂ ರಿಲೇಶನ್ಶಿಪ್ ಇರಬಾರ್ದು. A1 A3 ತಗೊಂಡ್ರು ಹಾಗೆ, A1 A5 ತಗೊಂಡ್ರು ಹಾಗೆ, ಎಕ್ಸೆಟ್ರಾ. ಅದೇ ಥರ A2 A1, A2 A3, A2 AN. So you consider any two different sets, there should not be relationship between one set element to another set element. So ಅದು disjoint ಇರಬೇಕು. That is the second condition. ಮೂರನೇ ಕಂಡೀಷನ್ ಏನು, if the union of all the n sets will give the actual given set, then we say that these are equivalence class of this particular relation. Okay, if any one condition is not satisfied, we can't say it as an equivalence class. Next we will discuss example number 6 in the textbook. So question ಈ ರೀತಿ ಇದೆ, let R be the relation defined on the set A is equal to 1 2 3 4 up to 7 by R is equal to A comma B such that both A and B are either even or odd. Show that this is an equivalence relation. ಮತ್ತೆ further we have to prove, this is the first part is equivalence relation ಅಂತ prove ಮಾಡಬೇಕು. Second part we have to prove that the subset 1 3 5 7 ಇದರಲ್ಲಿರೋ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟು ರಿಲೇಟ್ ಆಗಿದೆ. We have to prove that each element in this subset are related to each other, and similarly we have to prove that every element in this set are related to each other, but we have to prove that no element of this set are related to any element of this set. So first let us prove it is an equivalence relation. Equivalence relation anta prove madak munche relation ಏನು ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಫಸ್ಟ್ if you consider two ordered pairs, if you consider one ordered pair, the elements of the ordered pair ಎರಡು ಎಲಿಮೆಂಟು ಒಂದು ಇಲ್ಲ ಈವನ್ ಇರಬೇಕು ಇಲ್ಲ ಆಡ್ ಇರಬೇಕು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ if I consider 1 and 3, we can consider because both are odd, but I can't consider 1 and 2 because 1 is odd, 2 is even. So ಈ ರೀತಿ ಡಿಫೈನ್ ಮಾಡಬೇಕು ರಿಲೇಷನ್. So I can consider 1 and 3 but I can't consider 1 and 2. That is the meaning of relation. I can consider 2 and 4 because both are even, but I can't consider 2 and 3 because 2 is even, 2 is odd. ಇಲ್ಲ ಎರಡು ಈವನ್ ತಗೋಬೇಕು ಇಲ್ಲ ಎರಡು ಆಡ್ ತಗೋಬೇಕು. That is the given relation here. So let us prove it is an equivalence relation. Equivalence relation ಅಂತ prove ಮಾಡಬೇಕು ಅಂದ್ರೆ, so we have to prove that it is reflexive, it is symmetric, and also we have to prove that it is transitive. So how to prove that? Symmetric prove ಮಾಡಬೇಕು ಅಂದ್ರೆ, for every element of the given set we should have the ordered pair A belongs to relation. ನಮಗೆ ಗೊತ್ತಿದೆ, if you consider any element A and A, for example 1 and 1 ಅದು ಆಡೇ ಆಗಿರ್ಬೇಕು, ಎರಡು ಆಡೇ. 2 and 2 even, both are even. 3 and 3 both are odd. So it is satisfying the condition for any element of A and A, either it will be an odd number or it will be an even number. Correct? So if A and B are either odd or even, AB belongs to R. Here A and A is either odd or even, therefore A and A belongs to R. A comma A belongs to R, therefore R is reflexive. Now to prove that it is symmetric, first we have to take an ordered pair AB belongs to R. AB belongs to R ತಗೊಂಡು according to the given relation either both A and B are even or both A and B are odd. A and B are even ಅಥವಾ odd ಆಯಿತು ಅಂದರೆ B and A ನು ಸೇಮ್ ಕಂಡೀಷನ್ ಬರಬೇಕು. Therefore BA also belongs to relation, hence R is symmetric. Now transitive ಹೇಗೆ prove ಮಾಡೋದು? We need two ordered pairs. AB belongs to R and BC belongs to R. AB belongs to R means A and B both are either even or odd. B and C are either both even or odd. Both are either even or odd. So ಈಗ if I take, for example, ಎ ಆ್ಯಂಡ್ ಬಿ ಎರಡು ಈವನ್ ಆಗುತ್ತೆ ಅಂತ ತಗೊಳ್ಳೋಣ. ಮತ್ತೆ ಇಲ್ಲಿ ಬಿ ಆಡ್ ಆಗಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ. ಇಲ್ಲಿ ಬಿ ಆಡ್ ಆಗಲಿಲ್ಲ ಅಂದರೆ ಸಿನೂ ಈವನ್ನೇ ಆಗಬೇಕು. ಎ ಈವನ್ ತಗೊಂಡ್ಮೇಲೆ ಸಿನೂ ಈವನ್ ತಗೊಂಡಂಗೆ ಆಯ್ತು ಅಲ್ಲಿಗೆ. ಸೊ ಐದರ್ ಎ ವಿಲ್ ಬಿ ಈವನ್, ಎ ಆ್ಯಂಡ್ ಸಿ ವಿಲ್ ಬಿ ಈವನ್. ಸಪೋಸ್ ಇಫ್ ಐ ಟೇಕ್ ಬೋತ್ ಎ ಆ್ಯಂಡ್ ಬಿ ಆರ್ ಆಡ್, ಎ ಆ್ಯಂಡ್ ಬಿ ಎರಡು ಆಡ್ ಆಯಿತು ಅಂದರೆ ಇದು ಆಡ್ ಆಯಿತು, ಇದು ಆಡ್ ಆದಮೇಲೆ ಸಿ ಆಡ್ ಆಗಲೇಬೇಕಾಗುತ್ತೆ. ಸೊ ಎ ಆ್ಯಂಡ್ ಸಿ ಬೋತ್ ವಿಲ್ ಬಿ ಆಡ್ ದೆನ್. ಸೊ ಎರಡೂ ಕೇಸಲ್ಲೂ ಎ ಆ್ಯಂಡ್ ಸಿ ಐದರ್ ಇಟ್ ವಿಲ್ ಬಿ ಈವನ್ or it will be odd. So it is also satisfying the condition of given relation. So AC belongs to R. R is a transitive relation. R transitive relation aaytu. It is also reflexive. It is also symmetric. Therefore, it should be an equivalence relation. Next, we have to prove that, next part of this question, we have to prove that the elements of this subset are related to each other, and we have to show that the element of this set are related to each other, but no element of this set are related to any element of this. So let us prove it. The next part of this question is in the subset. So we have to show that in this subset every element is related to each other. That means in this subset what we can observe, 1 3 5 7, every element is odd number. So ಎಲ್ಲ ಎಲಿಮೆಂಟ್ ಆಡ್ ನಂಬರೇ ಆಗಿದೆ. ಕನ್ಸಿಡರ್ ಎನಿ ಟೂ ಎಲಿಮೆಂಟ್ಸ್, ಆರ್ಡರ್ಡ್ ಪೇರ್ ಅಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಎರಡು ಎಲಿಮೆಂಟ್ ತಗೊಳ್ಳಿ. ಯು ಕನ್ಸಿಡರ್ ಐದರ್ 1 and 3 both will be odd, 1 and 5 both will be odd, 5 3 and 7 both will be odd. So you consider any two number, both will be odd. So that is nothing but it is satisfying both A and B are odd. So it is satisfying the condition. So all the elements are odd. For any two elements both will be odd. So that means what? Every element in this set, so 1 is related to 3, 1 will be related to 5, 1 will be related to 7, so 1 will be related to 3, so 1 will be related to 5, 1 will be related to 7, so 3 will be 1 related to 1, 3 will be related to 5, 3 will be related to 7. So every element will be related to each other in this set. The similar case for second set also. In the subset 2 4 6, these all are even, all the elements are even. So any two elements you take, 2 4 ತಗೊಂಡ್ರೆ ಎರಡು even, 2 6 ತಗೊಂಡ್ರೆ even, ಅದೇ ತರ 4 2 even, 4 6 even, 6 2 even, 6 4 even. So you consider any two elements, both will be even. It is also satisfying the condition. So therefore all the elements of 2 4 6 are also related to each other. Now what we have to prove? We have to prove that no element of this set is related to any element of this set. So that is very obvious, because 1 and 2 if you take, 1 is odd, 2 is even. So both we can't have the same. That means what is the given relation? Either both should be odd or both should be even. If I consider 1 and 2, one will be odd, another one will be even. So we can't have that pair. So that we have to prove in the next case. So let us prove it. So next we shall prove that no element of 1 3 5 7 is related to any element of 2 4 6. So clearly if we consider one element from this set and another element from this set, what we will have? One will be odd number and another one will be even number. So according to the given relation, both numbers should be either it should be odd or it should be even. ಎರಡು odd ಆಗಬೇಕು ಅಥವಾ ಎರಡು even ಆಗಬೇಕು. ಒಂದು odd ಒಂದು even ತಗೊಳಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ. So if we consider these one element from this, one element from this, one element odd ಆಗುತ್ತೆ. ಈಗ for example 5 and 2 ತಗೊಳ್ಳಿ, 5 is odd, 2 is even, so we can't consider. ಅದೇ ತರ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ you consider one element from this, one element from this, we will have the ordered pair like this. One is odd, another one is even. So no such ordered pair belongs to the given relation R. So ಇದಕ್ಕೆ ಅಂತ ಯಾವುದೇ ordered pair ಸಿಗಲ್ಲ. ಅದ್ ಮೀನಿಂಗ್ ಏನು? What do you mean by that? Then what we can conclude, no element of this set is related to any element of this set. So that's what they has to prove. So here in this example what we can observe, it is satisfying all the three conditions of equivalence class. We proved that it is an equivalence relation. Then every element of these two sets are ರಿಲೇಟೆಡ್ ಟು ಈಚ್ ಅದರ್. ಈ ಸೆಟ್ಟಲ್ಲೂ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟು ರಿಲೇಟ್ ಆಗಿದೆ, ಈ ಸೆಟ್ಟಲ್ಲೂ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟು ರಿಲೇಟ್ ಆಗಿದೆ. No element of this set is related to any element of this set. Take the union of these two, you will get set A, right? So therefore these two are equivalence class of this set under the relation R, right? Okay, that's about the examples. So in the next video we will discuss exercise 1.1 ನಲ್ಲಿ ಸಿಮೆಟ್ರಿಕ್ ಪ್ರೂವ್ ಮಾಡೋದು, ರಿಫ್ಲೆಕ್ಸಿವ್ ಪ್ರೂವ್ ಮಾಡೋದು, ಟ್ರಾನ್ಸಿಟಿವ್ ಪ್ರೂವ್ ಮಾಡೋದು. ಅಕಸ್ಮಾತ್ ಸಿಮೆಟ್ರಿಕ್ ಅಥವಾ ರಿಫ್ಲೆಕ್ಸಿವ್ ಅಥವಾ ಟ್ರಾನ್ಸಿಟಿವ್ ಆಗಲಿಲ್ಲ ಅಂದರೆ ಹೌ ಟು ಗಿವ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಟು ಪ್ರೂವ್ ಇಟ್ ಇಸ್ ನಾಟ್ ರಿಫ್ಲೆಕ್ಸಿವ್, ಸಿಮೆಟ್ರಿಕ್, ಟ್ರಾನ್ಸಿಟಿವ್. ಆಗಲ್ಲ ಅಂದರೆ ಯಾವ ರೀತಿ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟು ಡಿಸ್ಪ್ರೂವ್ ಮಾಡಬೇಕು, ಅದನ್ನೆಲ್ಲ ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋದಲ್ಲಿ ನೋಡೋಣ. ಸೊ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋ ವಿಲ್ ಡಿಸ್ಕಸ್ ಮೆನಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವೆಶನ್ಸ್ ಫಾರ್ ಯುವರ್ ಎಕ್ಸಾಮಿನೇಷನ್. ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವೆಶನ್ಸ್ನ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಡೋಂಟ್ ಮಿಸ್ ದಟ್ ವಿಡಿಯೋ. ಅದ್ರ ಜೊತೆಗೆ ಈ ವಿಡಿಯೋ ನಿಮಗೆ ಇಷ್ಟ ಆಗಿದರೆ ವಿಡಿಯೋನ ಲೈಕ್ ಮಾಡಿ, ಶೇರ್ ಮಾಡಿ, ಹಾಗೆ ನಮ್ಮ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಥ್ಯಾಂಕ್ ಯು.